Welcome back to the lecture. We were studying about the geometric transformation and what are the types of geometric transformation. As we seen, the transformation is the process of changing the size of the object, changing the position of the object, rotating objects, and many more. Means any type of manipulation is called transformation, and we have studied about the different type of transformations. Let's go into the detail. The first type of transformation is translation. Translation is changing the position of the object, changing the position. Suppose we have an object in 2D and it has the point, suppose it's P point having the coordinates 4, 2, and we want to change the position of this point and the corresponding these points. Now we can change this position by changing in the x direction and in y direction. Suppose we have added some quantity in x direction and added some quantity in y direction, and now we have the point 5, 3, 5 and 3, and same applies on these points also. Now here we have a point P4, 2. We have transformed this point to P dash and named as x dash, y dash. How this happened? We have transformed this by changing P x y to P x dash y dash and x dash equal to x plus 1. We have changed the value of x coordinate 4 to 5, or we can say that we have incremented x by 1. In the same way, we have changed the position of y dash from here y plus 1, or from 2 to 3. Here we can say that how we get the x dash. We get the x dash by addition of some quantity into the all coordinate points x. It is the translation. These are the translation vectors, or we can say translation quantities. Now we can represent these as x dash equal to x plus tx. Tx is the translation vector in x direction. Here we have used 1. And in the same way, we can have y dash equal to y plus ty, translation vector in y direction. Means in the all coordinate points x and y, we can add some quantity and we can get the point x dash y dash. And how this can be written in the matrix form: x dash y dash equal to tx, ty and xy. From here we can see that it is the form. This is b, this t, and this a. b equal to t plus a. So here we will two quantities. b equal to t plus a. This forms looks very much familiar with the form which we have studied so far: b equal to t into a. This is the standard matrix transformation form. We have already studied as standard matrix transformation form: b equal to t into a. It is standard transformation matrix form. But in translation, we got b equal to t plus a. It is not the standard transformation form of the translation. Later on we will see that how we can convert this form into the standard transformation form or the general transformation matrix representation form. Now, second type of transformation is rotation. Rotating the object with respect to the origin. Here we will study only the rotation with respect to the origin by any angle. Suppose we have an object, we can rotate it in xy space, we can rotate it, suppose we have 30 degree, and it will be rotated like this, the rotation of the object. Then how we can rotate the object? Let's understand it with the help of a diagram. Suppose we have a figure and we have a point P xy in this space and another point P dash x dash y dash. Pxy all point P dash x dash y dash we get after the rotation. Now suppose this is making an angle phi with respect to the origin and this point is making an angle theta with respect to the origin. Now the point P dash is making the total angle of theta plus phi. Now it is r, it is also r. This is the point P dash x dash y, so this distance is x dash. It is point xy, this distance is x. From this, how we can get the rotation matrix? As we know, base upon hypotenuse means x dash base upon hypotenuse, x dash divided by r is equal to what? Having the theta, angle theta plus phi, base upon hypotenuse is equal to cos theta plus phi, because here we are making an angle with respect to the origin, that is theta plus phi. Also we can see that it is y dash, then y dash divided by r is equal to sin theta plus phi. When we will take the point Pxy, then we can get x divided by r equal to, it's making an angle phi cos phi, and y divided by r, y divided by r equal to sin phi. Now let's solve these equations. From this equation 1 we get x dash equal to r cos theta plus phi. From this equation second we got y dash is equal to r sin theta plus phi. From this equation third we get x equal to r cos phi, and from this equation fourth we get y equal to r sin phi. Now let's rename these. It's the equation 5th, 6th, 7th and 8th. Now let's solve the equation 5th and 6th, as we have x dash equal to r cos theta plus phi as we know cos a plus b is equal to cos A cos B minus sin A sin B. Now apply this formula in this equation. X dash equal to r cos theta plus phi. Here we as x dash equal to r cos theta cos phi minus r sin theta sin phi. Now in this equation we know that r cos phi, from here we know that r cos phi is equal to x and r sin phi is equal to y. Now put the value of r cos phi, that is x cos theta minus r sin phi will be y, and put the sin theta minus y sin theta. Now we got this equation, x dash equal to x cos theta minus y sin theta. In the same way, solve the equation y dash equal to r sin theta plus phi. Sin A plus B, sin A cos B plus cos A sin B. Y dash equal to r sin theta cos phi plus r cos theta sin phi. Now from here y dash equal to, again we know r cos phi is equal to x, then x sin theta plus r sin phi is y, then y cos theta. We got the equation x dash and y dash. Now we will represent the equation. We have x dash equal to x cos theta minus y sin theta. Y dash is equal to x sin theta plus y cos theta. Now how we can represent this in transformation matrix form? It can be represented x dash y dash is equal to cos theta minus sin theta cos theta and x y. Now we can see that it is b is p and it is a, or we can say that we have a form b equal to p dot a, that is standard matrix form. So for rotation we got the standard matrix form that we will use is this. It is transformation matrix, or we can say the transformation matrix for the rotation. Now by putting the value of theta, suppose theta is 90 degree, then in place of theta we put the 90 degree and we will get the rotation matrix for the angle 90 degree.